one that's interacting with another amino acid. And we'll count it by the nitrogen. So if this is nitrogen 1, because the blue balls are kind of easy to see. This is nitrogen number 2. That makes out alpha carbon. There's another carbonyl group. But that makes this nitrogen number 3, alpha carbon side group. Hydrogen, that must be a carbon for the carbonyl. And it has to be bound to another nitrogen, so that must be nitrogen number 4, amino acid number 4. Alpha carbon, hydrogen side group, that must be, that's a carbon with its oxygen. And this must be nitrogen number 5. So we were right, the carbonyl from amino acid number 1 is interacting with the amine group from amino acid number 5. So it's 1 interacts with 5. And likewise, 2 interacts with 6, and 3 interacts with 7, and 4 interacts with 8, and so on. Yes? Those hydrogen bonds form stabilizing forces that hold that alpha helix in place, but it's not the only force that's holding an alpha helix in place, right? If you look down the length of this alpha helix, if your eyeball was up here, and you were looking this way, you would not see an open cylinder, even though this looks like it's a cone, because all the electrons from all the side groups and all the other atoms that are stuck onto this backbone, once you fill the space with those, there is no empty space after that. So these are more like rods than cylinders, okay? If I ever asked you what are the stabilizing forces that hold alpha helices together, your answer would be hydrogen bonds from carbonyls and amine groups 4 amino acids away, plus a crap load of something else. What would that something else be? Anybody listening to my story? Next. What forces can occur between any two atoms? Van der Waals. So if you're sticking all these atoms together so that there's no space between them, doesn't it have to be van der Waals? Because we know it's not covalent, right? Because covalent's only cysteines. And that usually bends a polypeptide. We're not looking at bending polypeptide, we're looking at a helical structure where the amino acids are not bent around, so it can't be covalent. There's no ionic bonds, because none of those atoms are charged. We don't know what the side groups are, but none of the atoms are charged. And so the only thing left are hydrogen bonds and van der Waals. Capiche? That's Italian for, do you understand? Here's another thing I'm going to point out, and I think it's going to come up again later. Look at the R groups. There's one, there's one, there's one, there's one, there's another one, there's another one, there's another one, there's another one. If you looked on the back, there would be another one. In alpha helices, the R groups are always perpendicular to the axis of the helix. So if you were looking like you were looking here, if you were looking down the length of the helix, the R groups would be out here. Like spokes on a tire, I guess. Okay, there'd be some facing us too, and some into the board, but there's none of them tucked inside the helix. They're all outside. Okay.
I'm sorry, you said they're perpendicular to what?
The axis of the helix. And so I'm calling the axis of the helix a line, imaginary line that goes right down the center of the helix. That's the axis of the helix. Why do you keep my ball? Why do you keep eyeballing me?
So perplexing.
Let's see, what else are we going to talk about? Herb?
No, I'm saying.
Time to go. It's 2:29 then. So, let's have some questions then. Tina? How you doing? Okay. I graded your quizzes from lab yesterday. My plan is to give them back next lab period, because there's so many of them, I don't want to take class time. And I don't have them with me now, but if you want to come to my office hours, you want to see, your grade's already posted on Blackboard, so if you're interested in what you got, look there, but if you're interested in why you got it, then come see me, or we can talk next week. If you want to talk about your lab results, we'll do that